Welcome back. In this video, we're going to look at how geometric series relates to repeating decimals. In fact, we're going to see how we can use geometric series to actually express first a repeating decimal as a geometric series, which we can then simplify to get its fraction version. Okay, so here's how we work with that 0.62, 0.62, 0.62. Is we think of that as a sum as follows. 0.62 plus 0.0062 plus 0.00062 and so on forever. All right, so there's your infinite series. We have an infinite sum now. And we want to find a way to express that as a geometric series. So here's what I want you to kind of observe. The difference between our first one there, 0.62, and the second one is 2 decimal places. So you can accomplish that, moving the thing back 2 decimal places, by dividing by 100, or alternatively, by multiplying by 1/100th. Either way, divide by 100 or multiply by 1/100th. And then moving it 2 more places would be to divide by 100 a second time, or again, multiply by 100th twice. And so on and so on. So we can write this then as the sum as k goes from 0 to infinity, where a is that 62 hundredths, 0.62, that's 62 hundredths, and the ratio is just 0.01. So times 0.01 now to the k power. Okay. And now that we've written it as a geometric series, we can say that's just a, 0.62, divided by 1 minus 0.01, and that would be 0.62 over 0.99, and that would just be 62 over 99, because we can just multiply both top and bottom by 100 to move the decimal place to get rid of the decimal points. And so we have a fraction 62 over 9. So 0.62 repeating is just the fraction 62 over 9. Okay, so that's how we can use geometric series to express a repeating decimal. Okay. Now, I want to show you one final thing here, what this kind of observation gives us. So what that means is if you have the decimal 0.9 repeating, all right, well, you could think of that as 0.9 plus 0.9 times 1/10 plus 0.9 times 1/10 squared, and so on. So that would be the sum as k goes from 0 to infinity of 0.9 times 0.1 to the k. And then using our formula, we get 0.9 divided by 1 minus 0.1, which would be 0.9 over 0.9, which would be 1. So in other words, 0.9 repeating is actually just another name for 1. And so we have this conclusion. If we have 0.9 repeating forever, that's actually just 1, which is kind of a cool, interesting idea there. 0.9 repeating forever is actually just another way of saying 1. And so that's a pretty cool, unique consequence. And we can see that, and we're able to see that with infinite series. So It's a pretty neat idea there.